Hello everybody and welcome to Chapter 4, Lesson 5, Solving Quadratic Equations Using the Quadratic Formula. The essential question for today is how can I use a quadratic formula to find the solutions of a quadratic equation? What you will learn is how to solve a quadratic equation using the quadratic formula, how to interpret the discriminant, and how to choose an effective method for solving quadratic equations. All right, so let's start off with what is the quadratic formula. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this happens when a is not equal to 0, and then this piece right here, which is called the discriminant, when that is also greater than or equal to 0, okay, which means that whatever this is in here should not be equal to a negative value, otherwise we have no real solutions. So this is coming from standard form of a quadratic function. So ax to the power of 2 plus bx plus c. So with a quadratic equation, something set up like this, we take the numbers a, b, and c, we replace them into our quadratic formula, and it gets us our solution or solutions. So example 1, we're going to use the quadratic formula to find the solution or solutions to our quadratic equation 2x to the power of 2 minus 5x plus 3 is equal to 0. All right, so first thing I'm going to do is I'm just going to write out my quadratic formula. X equals negative b plus or minus the square root of b to the power of 2 minus 4 times a times c all over 2a. All right, so then what I'm going to do is I'm going to take all of my terms and I'm going to go ahead and substitute them with the values that are in my quadratic equation. So the first thing I'm going to do is I'm going to go ahead and go in order. So I'm going to replace my a values. So a, okay, both of those get substituted with a 2 because that's our a value. So a is going to be 2. Here was a 2. All right, then I'm going to go ahead and replace the b terms with a negative 5. So this b becomes a negative 5, and this b becomes a negative 5 as well. And last but not least, we're going to go ahead and replace our c, the only c that we have there, with a 3, a positive 3. A little hard to see that it's a 3. There we go. All right, and then all we're going to do is we're going to follow our order of operations and solve this problem out. So what I want to do is I'm going to take it just kind of by parts. I'll color code it so you guys can see where everything's going. The good thing about the quadratic formula is you can kind of take different pieces all the way around. So I'm going to do this. Simplify that. So that's negative 5. So I'm going to say x is equal to, and then that becomes a positive 5 because negative times a negative is a positive. I have plus or minus. We'll get to this part in a second. And the square root. All right, so I'm going to do the exponent here. Negative 5 to the power of 2 is 25. Negative 5 times negative 5 is a positive. Then I'm going to multiply these three numbers. 4 times 2 times 3. So that's going to be 4 times 2 is 8. 8 times 3 is 24. Okay, and then I'm going to put that all over 2a, which is 2 times 2. So this here becomes just a 4. All right, so you see how it just took pieces of the operation and I brought them down. All right, so then there's still some more to simplify, so I'm gonna go ahead and do the inside of my square root. So I have 5 plus or minus the square root of something over 4. So I'm gonna do, let's see, red. This, 24 minus 25, that's 1. All right, so then that's that, and then I'm gonna go ahead and simplify that a little bit more. So I'm gonna have 5 plus or minus over 4, and then what I'm simplifying right now is the square root. So the square root of 1, that's going to be just 1. The square root of 1 is 1. So we have 5 plus or minus the square root, 5 plus or minus 1 over 4. So then what I'm going to do is, this is actually going to give me two answers, right? Because of this plus or minus, that means that I want two different things. So what I want is I have x equals to 5 plus 1 divided by 4, and x equals 5 minus 1 over 4. Okay, so I have two values that I'm going to get as my solution. So I'm going to add my numerators or subtract my numerators. So over here I'm going to get 6. Over here I'm going to get 4. So I have x is equal to 6 over 4. This one's going to be x is equal to 4 over 4. So all I'm going to do is I'm going to simplify. So this is 3 over 2, and this one is just 1. So my two solutions to my quadratic equation are 3 over 2 and 1. So right here I'm going to put x is equal to 3 over 2 and x is equal to 1. Those are the solutions to the quadratic equation 2x to the power of 2 minus 5x plus 3. Okay, so what we can actually do is we can find out before we do the quadratic formula whether a quadratic equation has two real solutions, one real solution, or no real solution. So let's see, so what we know is we know how to look at the graph, right? So if I look at this graph right here, I know it has two solutions because it passes through the x-axis at two different points. So that one has two real solutions, and it also has two x-intercepts. This one in red over here has one solution because it passes through the x-axis only at the vertex. That one has one solution because it has one intercept. And then this one here, because it does not ever touch the x-axis, then we have no real solutions because it has no x-intercepts. Okay? All right, so then we're going to get into talking about this piece right here, b squared minus 4ac. And if we think back to our quadratic formula, that's this piece right here. This piece inside the square root, that is our discriminant. So we can find out whether our equation has one solution, two solutions, or zero solutions if we just focus on this piece of our quadratic equation. So going back here, if our discriminant b squared minus 4ac is greater than 0, meaning it's a positive number, okay, then it's going to have two solutions, two real solutions, okay, if it's a positive number. If it's equal, if it's exactly equal to 0, if whatever's in the discriminant ends up being 0, it has one real solution. And if it is less than 0 or negative, then it has no real solutions. Okay, and let's think back over here why that makes sense. Okay, if this is negative, this that I circled here is negative, right? We're going to get the square root of a negative number. And we all know that we can't take the square root of a negative number to get a real number answer. Okay, so we will have no real solutions in that case. Right, so here are what we're going to be looking at. We'll come back to it if we need it. All right, so here's example 2, part A. So we're going to determine just the number of real solutions. So right here, instead, I don't want to know what the solutions are. I want to know how many solutions there are. So if I start off with just my equation, okay, and all I'm going to be doing is b squared minus 4ac. This is my discriminant. Okay, so I'm going to substitute my b. I'm going to substitute the a and the c with values from the equation that we have on part A. So we have b squared. B is 8, so I'm going to replace the b with an 8. A is just a 1. There's no number in front of the x squared, so it's a 1. And then c is a negative 3. Okay, so here we're going to go ahead and follow our order of operations. Let's do this. 8 to the power of 2 is 8 times 8, which is 64. Okay, I'm going to subtract, and then I'm going to multiply all of these. 4 times 1 is 4, times negative 3 is negative 12. And then I have a negative and a negative, so this becomes a positive. So then this becomes 64 plus 12, which is 76. Because this is a positive, okay, because it's a positive or greater than 0, that means that this quadratic equation is going to have 2 real solutions because the discriminant is positive. Okay, let's try one more. So this one is not in standard form, so we're going to have to do something to the equation before we use the discriminant. Okay, so in order to substitute into the quadratic formula or to use the discriminant, we have to have this written in standard form. So what I'm going to do is I'm going to move the 6x to the left side by subtracting it to both sides. So I can get equal to 0. We need it to be in standard form. Okay, so that's what we're going to do here. We have 9x to the power of 2 minus 6x plus 1. Okay, so now we have this here. Let's label A, this is B, this is C. So now what I'm going to do is I'm going to write my discriminant and see if this has 1 solution, 2 solutions, or 3 solutions. So our discriminant is b squared minus 4ac. Okay, so I'm going to need a b to the power of 2 minus 4 times a times c. So I'm going to take the numbers from the equation that I have now in standard form. We have b squared, so b is negative 6, a is 9, and c is positive 1. Okay, so now let's try it out. Let's do my exponent. Negative 6 to the power of 2 is negative 6 times negative 6. Negative times a negative is a positive 36 minus 4. Not 4. Let's multiply that. 4 times 9 times 1, that's 36 times 1, it's just 36. So we can see here we have 36 minus 36, which is 0. Okay, so 0 is our value. So if we come back here, if we have the discriminant equal to 0, then we have 1 real solution. 1 real solution because our discriminant is equal to 0. All right, that is the end of our lesson. In this lesson, you should have learned what is the quadratic formula. You should have learned what the discriminant is and what it does and what it tells us actually. So if you have any questions, comments, or concerns, please feel free to drop them in the comment section down below. Thanks for watching. See you next time.